When we discussed the activity of simple perceptron-like neurons, we calculated how active a neuron was by using a simple weighted sum labelled S in the diagram on the screen. However, a little thought will indicate that this won't work well for pulsing neurons. When pulses are present, we'll get lots of activity, and when none are present, we'll get no activity. And the activity will jump instantaneously between these two levels. What we actually need is some way to assess the activity over a longer time period, to produce a large activity if lots of pulses are being received, and a small one if only a few pulses are being received. This can be done by adding up the number of pulses over a time period. One simple way of doing this is by using what's called a leaky integrator, which is shown on the diagram on the screen. Here, A represents the current activity of a neuron, and A superscript minus the activity from the previous time step. Alpha is a constant less than 1. This means that if there were pulses in the previous time steps, then they will be included in the current activity by the A superscript minus term. But if there were no pulses, the activity will slowly decay away towards 0, because alpha is less than 1. The diagram now on the screen shows the idea. As you can see though, such systems are more complicated because they demand that we take account of time in the network, which we didn't do in the simpler networks that we've dealt with up until now. And in our next video, we'll discuss how to do this.